Okay, so this is the second video for chapter 12. And what I'm going to do now is kind of go through the book and show you how to set up some of these various simulations. And I'm going to try to break the setup into 3 videos. And then in the 4th, I'm going to try to bring everything together in one spreadsheet, in order to calculate this expected profit. So the idea here, just real quickly, you guys should be reading the book, but this company called Portacom, their direct labor cost, parts cost, and first-year demand are unknown. So they think each of these, well, the 2 costs and the labor demand, follow different probability distributions. And so our task is to take those various probability distributions and create a simulation in Excel. So this first one is for our direct labor costs. And the idea here is the firm believes that labor can be $43, $44, $45, and this is direct labor costs per unit. So $43 per unit, $44, $45, so on and so forth. And then what they do is assign a probability. So this is going to be a discrete probability distribution. But most importantly, what's nice about this model is this can handle any probability distribution. And I'll explain that a little bit later. I like the way this is set up because this is the way most random variables are generated, right? If you really think about it, most random variables in this world don't come from a normal distribution, the t-distribution, what have you, right? Those distributions are very specific to certain situations, right? And this particular way allows the practitioner to basically create his or her own probability distribution. All right, so I'm gonna get into a little more in that later on in the video. First, let me just show you how to do this, and then we'll talk about some extensions. So the idea here is I have a discrete probability distribution. So in other words, there's a 10% chance that the direct labor cost will be $43 per unit, 20% chance of 44, so on and so forth, all right? And this table, this table that I've got here, you can find this table on page 556. It's table 12.3. Okay, well, if you think about it, any probability distribution, right, the probability has to sum to 1. And so that's what I'm showing you here. So when you take this to your job and you're going to create your own probability distribution, make sure that the distribution you have created sums to 1. And that's what I'm trying to show you here, all right? So the idea here is, okay, so what does it mean to have a probability of 10%? Well, that's anything between 0 and 0.1, right? And then a 20% probability, well, that's going to be anything from 0.1 to 0.3. And then a 40% probability, well, that's anything from 0.3 to 0.7, and you get the rest. All right? So then the question becomes, all right, what function do we use that generates a probability between 0 and 1? Well, that function is here. It's called the rand function. It's another volatile function, and it's super easy. You don't have to do anything, right? The function requires no argument. This function follows a continuous uniform distribution in the interval between 0 and 1. So Excel is going to randomly generate a number between 0 and 1. Hit OK. And I mean, like, this is what I mean by it's a continuous distribution, right? I can show you this. I'll take this out a little bit farther. Add. I mean, well, actually, okay, so it stops here. But, there's an infinite number of numbers that Excel can randomly generate with this function. Okay, so what I'm trying to get at is, I'll shorten this up again. Oops. Maybe I better shorten up there we go. Okay, so this is the probability that's associated with my probability, right? So here I've randomly generated a number, 0.38. Well, 0.38 is going to fall in this range of my distribution. So in other words, when I randomly generate any number between 0 and 1, right, I'm going to use that number, look in this interval, and find out what direct labor cost that number is associated with. All right? To do that, I'm going to use the VLOOKUP function. Now that's in your book, your author talks about it, but I want to make it easier for you. The way your author set up the table, you don't have to do all that. You don't have to do all that. So I'm going to make it a little bit easier on you. So here, this is going to be my table. So I need my probability here, okay? What you're going to want to do is you put the lower bound of your intervals here. So I'm going to put a 0, and then I'm going to put a 0.1, then I'm going to put a 0.3, a 0.7, and a 0.9, okay? Because remember, the idea here is if I get like a 7.73, that's going to be in this interval. And the reason you put the lower bounds of your intervals in your table is because of the way the VLOOKUP function works. So now let me show you how to do that. So the VLOOKUP is a function in Excel, so just go to your function wizard. Type I have it ready, but you might have to type it into the search for a function. And here you go. So what do we need? First, we need a lookup value. So this is the value that is to be found in the first column of your table. Well, for our purposes, that's the rand function, all right? And then I need the table itself. And this is what I wanted to show you. Your author has a bigger table. You don't need it. Your author actually breaks it down, and he puts in the lower bound, and then he puts in the upper bound for each interval, and then he puts in your direct labor cost. You don't need the upper bound. It's just a waste of time. You just need the lower bound. So I'm going to highlight my entire table, okay? I got the lower bound of my probability intervals and my direct labor cost. And then I need a column index number. So what's happening here, the way the VLOOKUP function works, is it says, okay, this is my lookup value. So I'm going to look up this value in the first column of my table, okay? And then I'm going to return a number. Well, that's what the column index number is. You have to tell Excel what column contains the number that you want it to return. In our case, that's column 2. We want it to return the direct labor cost, all right? And then finally, you have the range lookup. So the range lookup is a logical statement. It equals true if you find a close match, or false if it's an exact match. Obviously, for our purposes, we want to type in true. We're not always going to find exact matches, right? Here, there's no exact match to 0.7333514. So the VLOOKUP says, hey, there's nothing in there. It's not going to return anything, right? So we want to type in true. Or you can omit it. You can omit true. All right, so I'm going to hit OK. Okay, so what's going on here? So I have this 0.63. So what Excel does is it finds the smallest value that is greater than 0.63 from my table and returns whatever is in that row in column 2, right? So this 0.63, that is in this interval, right? If I break up my distribution, you know, the first 10% is in interval 1, and then I got 20% in interval 2, so on and so forth, right? So this 0.63 is found in this interval, right? So what the VLOOKUP does is it finds the smallest number that is greater than your reference cell, your lookup cell. Okay? And again, this is why you always put in the lower bound. You never ever put in the upper bound, right? Why? Because of the way the VLOOKUP function works. All right? So at any rate, I hope that makes sense. We'll go through it in class as well. But that's it. So this is a way that we can randomly generate direct labor costs from this probability distribution. All right? And then, of course, we want to simulate this. So to simulate it, it's very, very easy. So all you have to do is go into your VLOOKUP function and anchor the table. That's it. So I'm going to put a $sign in front of the 2, a $sign in front of the 6, and now I've got that anchored. Notice I still want this to be a volatile function. So now watch. To run my simulations, all you have to do is copy these 2 cells down, right, for as many simulations as you want to run. So I'll copy them down just a bit there. And voila. Here are all of my simulations, right? The RAND function is randomly generating a number between 0 and 1. And my VLOOKUP function, because I have it properly anchored, right, it's still using that same table. So for this one, it's got the 0.244. So VLOOKUP says, well, what is the smallest number, right, larger, well, maybe I said that wrong. What's the largest number that is smaller than 0.244, right? Well, that's the 0.1, so it's going to return the 44, and if I hit enter, well, quick rats, now it moved, but it would have been 44 had I copy pasted all the values. But at any rate, that's how we generate or create these simulations using our own probability distribution. So earlier I said this method is very nice because it allows for any probability distribution that you think is appropriate. And so what I mean by that is, like in this simple example, you can just insert a few new rows, right? So now let's say my direct labor costs are 43, well, 44, say 45, 46, 47, 48, 49, and 50, right? Okay, so now what I have to do is assign a probability of getting one of these direct labor costs. So let me do this. Let me put in, I'll do a 0.1 here. Let's see, I'm going to do a 0.2 here. I'll do a 0.1. Oops, I don't know what happened there. I'll do a 0.1, and then I'll do a 0.1, and then a 0.1 here. Okay, now the reason what I'm trying to show you is, look, the sum is still 1. These probabilities in your distribution must always sum to 1. If they do not, you are going to be making a huge mistake when you run the simulation. All right? So now again for my interval, this first interval goes from 0 to 0.1. And then I go from 0.1 to 0.3 because my probability is 20%. And then I go from 0.3 to 0.4, 0.4 to 0.6, and then 0.6 to 0.7, 0.7 to 0.8, 0.8 to 0.9, and then 0.9 to 1. And so you should always end up with a 1, right? The upper limit on the last interval should always be 1. All right? And then all I got to do is change my table. So here I still have a 0. I have the 0.1, but now this is 0.3, 0.4, 0.6, 0.7, 0.8, and then I got my 0.9. And then here I just change up. Oh, it worked. Oh, I didn't have to change anything, right? Because I inserted the rows in my table, so my VLOOKUP function remained, or incorporated those those new rows. So there, I'm done. So this allows me, right, to make as many changes as needed or as appropriate for the situation that you might be simulating. And once again, notice how this works. So this first one gave me a 0.43. Well, the 0.43 should be in this interval, right? So I should be getting direct labor costs of $46, and by George, that's exactly what I have. All right. Another thing, these labor costs are discrete units. Even the costs don't have to be. This could be 43.5, 43.75, 45, 45.82, 47.02, 48, 49.56. So you've got a lot of flexibility. That's what I'm trying to get at. Setting up your simulation with your own probability distribution allows you a tremendous amount of flexibility. All right. Again, just make sure that your probability sum to 1. Make sure that in your interval, the upper limit of the last interval is 1. Make sure that in your VLOOKUP table, you always put in the lower limit for your intervals, and that's it. And then, just copy these down, as many rows as you need to create as many simulations as you need. And there you go, a very easy way in Excel to create some simulations based on your own probability distribution. Now, I keep harping on this, you're based on your own probability distribution, right? Well, the reason for that is, like in financial planning, where you're going to try to model, say, the S&P 500 returns. Well, it's not clear that the returns to the S&P 500 follow a known distribution, right? It's not clear that the returns follow like the normal, the t-distribution, the binomial distribution, the chi-square distribution, blah, 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 right? So instead, what you're going to do, or what I would do, is I would get some data on the S&P 500 returns and then create my relative frequency distribution, and those would be the probabilities that I would use to model future S&P 500 returns. And that's something we'll get into next week when we apply simulations to financial planning situations. This week is all about getting you used to running simulations in Excel. All right, so as usual, I've spoken a little bit too long, but here is how to model a simulation where you create your own probability distribution. And this also simulates the direct labor costs for the problem in the book that I'm going over. All right, so in the next example, we're going to simulate a random variable that follows a normal distribution, and then after that, we're going to simulate a random variable that follows a continuous uniform distribution. And then the last video, we're going to bring all this together and simulate the Portacom